Today we are going to have questions of examples solved in the NCRT, but we will do it in our own way. Okay, so I'll let you know how to do them. Okay, so and one more thing, my channel is going to give you full support for class 11, 12 board exams as well as NEET. Hey, it is all free of cost. So just subscribe to my channel and do share with all your friends that they will be benefited and help me to grow this channel for next time. And I need your help to do all this. Thank you so much. Let us start. Okay. So today's session, hello. Question, we will solve examples. Wait. Okay. So examples of solution chapter. First question is calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. So you know what is ethylene glycol? It is CH2OH, CH2OH. Okay. So 20% of ethanol by mass is given to us. So 20% of ethylene glycol by mass means what it means. What it means? It means 20 gram of C2H6O2 is present in 100 gram of solution, or because total solution is 100 gram, out of 100 gram 20 gram is ethylene glycol, so that means 80 gram of water. So we have 80 gram of water, 20 gram of ethylene glycol and 80 gram of water. To calculate mole fraction of ethylene glycol, what is the formula used? Yes, beta. What is the formula used? It is number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water. This is the formula used. Okay. So now, as 20 gram of ethylene glycol we have, 80 gram of water we have. Means mass of ethylene glycol and mass of water, it is given to us, because 20% of ethylene glycol. So what we need? We need number of moles, and to calculate number of moles we need molar masses, because number of moles equal to mass of ethylene glycol divided by molar mass of ethylene glycol. And for water, weight of water divided by molar mass of water, right? So molar mass of ethylene glycol is, what is molar mass of ethylene glycol? 12 into 2, 1 into 6, 2 into 16. Because you know atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. So it is 24 plus 6, 30 plus 32. So it is equal to 62 gram per mole, right? Now, molar mass of water, that you know, 18 gram per mole. So number of moles of ethylene glycol is equal to 20 over 62, and number of moles of water 80 over 18. So 20 over 62. So it is 0.32, and for water it is 4.44. Okay. So now mole fraction of ethylene glycol is equal to number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water. So it is 0.32 divided by 4.76. So it is 0.32 divided by 4.76, means it is 0.0672. So this is the mole fraction of ethylene glycol, and that we have to calculate. Question is, what is, calculate the mole fraction of ethylene glycol. So mole fraction of ethylene glycol comes out to be 0.0672. So, yes, but understood? Hello? Yes, but understood? Mole fraction of ethylene glycol is 0.0672. Next question. Calculate the molarity of a solution containing 5 gram of sodium hydroxide in 450 ml of solution. So in this case, mass of sodium hydroxide is given to us, volume of solution is given to us. Now by using these two, mass of sodium hydroxide and volume of solution, can calculate molarity. So molarity is equal to, what is the formula? Weight of solute over molecular weight of solute into volume of solution. If it is in ml, then it is multiplied by 1000. This is the formula used. See, weight of solute is given to us, that is weight of NaOH. So what is required? Molar mass of NaOH we need to get the molarity, because volume is given in ml, and for that we multiply it by 1000. So molar mass of sodium hydroxide is Atomic mass of sodium is 23, oxygen is 16, and hydrogen is 1. So it is 40 gram per mole. So molarity of solution, that is capital M, is equal to 5 gram into 1000 ml per liter, 40 gram per mole into 450 ml. So ml cancel, gram cancel, answer become mole per liter. So it is equal to 5000 divided by 40 divided by 450. It is 0.28. It is about 0.28 mole per liter. This is the molarity of the solution. 0.28 mole per liter, or it is 0.2777. You can write it as 0.278, or if you round off to two significant figures, it is 0.28 mole per liter. Next question. Calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. So see, what is given? Weight of solute, that is ethanoic acid, it is 2.5 gram, and weight of solvent is also given to us. Solvent is benzene and it is 75 gram. And what is the formula of molality? So molality is small m equal to weight of solute over molecular weight of solute into weight of solvent in gram multiplied by 1000. What is left? Only molar mass of ethanoic acid we need. So molar mass of ethanoic acid is 2 carbon is 2 into 12, 4 hydrogens, so 4 into 1, and 2 oxygens, 2 into 16. So it is again 24 plus 4 plus 32. That is 60 gram per mole. Is 60 gram per mole. So just put the values. 2.5 gram divided by 60 gram per mole into 75 gram into 1000 gram per kg. This 1000 is 1000 gram per kg. So it comes out to be 2.5 into 1000. It becomes 2500 divided by 60 and divided by 75. So it is 0.56 mole per kg. So molality of the solution comes out to be 0.56 mole per kg, or in three significant figures it is 0.556 mole per kg. It is up to you. Next question. Next question is, vapor pressure of chloroform and dichloromethane at 298 Kelvin are 200 mm Hg and 415 mm Hg. So let us say that's chloroform as A. Take it as A, and dichloromethane as B. So P naught A is equal to 200 mm of Hg, P naught B equal to 415 mm of Hg. To calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of dichloromethane at 298 Kelvin. So first we have to calculate vapor pressure of the solution, and second, mole fraction of each component in the vapor phase. So let us write first the formula is used. So for the first question, what is required to calculate vapor pressure of the solution? We know that vapor pressure of the solution is equal to P naught A plus P naught B minus P naught A into XB, right? Because P equal to PA plus PB, and according to Rawls law, PA equal to P naught A XA and PB equal to P naught B XB. So P naught A XA is 1 minus XB plus P naught B XB. So it is equal to P naught A plus P naught B minus P naught A into XB, right? So now say P naught A we have, P naught B we have, but we don't have XB. So just expand it. What is XB? Number of moles of B divided by number of moles of A plus number of moles of B. So now number of moles we don't have. So just expand it further. Number of moles of A equal to weight of A over molar mass of A. Now weight of A we have. Calculate number of moles of B. Weight of B over molar mass of B. So WA and WB we have, but we don't have MA and MB. Just calculate MA. That is MA. A is chloroform. So that is equal to 1 into 12. 1 into 1 plus 3 into 35.5, right? So in this way, it is equal to 35.5 into 3 plus 13. It is 119.5. 119.5 gram per mole. That is MA. Now MB. MB is CH2, Cl2 is dichloromethane. So it is 1 into 12 plus 2 into 1 plus 2 into 35.5. So value is 2 into 35.5, 71 plus 14. That is 85 gram per mole. Right? So now MA and MB we have, WA, WB we have. So just go back now. Calculate NA. So NA equal to WA. What is WA? 25.5 divided by 119.5. Okay. So it comes out to be 25.5 divided by 119.5, that is 0.213. Okay, now number of moles of B. So now weight is 40 over 85. It is 0.471. 0.471 and 0.213. So from these two, calculate the mole fraction. Formula we have, that is NB upon Na plus Nb. So 0.471 divided by 0.213 plus 0.471. Zero point two one three plus 0.471, that is 702. 702? 0.213. Sorry, it is 0.213. 0.13 plus 0.471 is 0.684. So what is the value? 471 divided by 684, that is 0.6888. So take it as 0.69. So mole fraction of solute, that is, there is nothing like solute and solvent, but for mole fraction of B means dichloromethane is 0.69. So just put the value in the equation. So P equal to P naught A. P naught is 200 plus P naught B minus P naught A, that is 415 minus 200 into 0.69. So total vapor pressure equal to 200 plus 215 into 0.69. 215 into 0.69, that is 148.35. And plus 200, that is 348.35. mm of Hg. So this is the vapor pressure of the solution. This is the answer of the first question. And what was the first question? That vapor, what is the vapor pressure of the solution? So vapor pressure of the solution we have calculated, and that is equal to 348.35. Okay. Now second part, and if we take it exact value, that is 0.688, then if we take it as say 348.35, it is acceptable answer. Okay, but if we take exact value, that is 0.688, next is 5, so then value comes out to be then value is then it is 147.92. Then P comes out to be 347.92. Otherwise, it comes out to be 348. If we take it as 0.69, it was 348.35. Means roundabout P is 348 mm of H. It is roundabout 348 mm of Hg. You can take it as 347.92, 348.35. Okay, it is the almost exact. It is the estimate, and average value comes out to be 348 mm Hg. Now next part. Sorry. Next part of the same question is mole fraction of each component in the vapor phase. Yes, beta. How do we calculate mole fraction? Let us take Ya, Yb, mole fraction of each component in vapor phase. So what is the formula used? Yes, beta. What is the formula used? What is Ya? Ya equal to, yes, beta. What is Ya? Ya equal to Pa. Yes, beta. Ya equal to, in vapor phase it is Pa over P total, or P we can say. We have written it as P. We can write it as P total as well, because it is vapor pressure of the solution. So if we take it as P, so it is Pa upon P, or we can say it is equal to Pa divided by Pa plus Pb. This is the formula used. But P we know, so just calculate Pa and Pb. And what is P? Yb? Yb equal to Pb upon P total. This is the formula. That is the mole fraction of each component in vapor phase. This type of question we have done before. Now, Pb, and you know Ya plus Yb equal to 1. Ya plus Yb equal to 1. So if we calculate Yb, so Ya equal to 1 minus Yb. Okay. So Yb, to calculate it, Pb equal to P naught B into XB. So P naught B we have, that is 415, and XB it is 0.688, or you can take 0.69. So 415 into 0.688. It is 285.52. mm of Hg. So from here, YB equal to PB. What is PB? 285.52 divided by P. P total is 348 or 347.92. So it is just divided by 347.92. So it is 0.82. This is mole fraction of component B in vapor phase. So what is YA? 1 minus YB, that is 1 minus 0.82, that is 0.18. YB is 0.82 and YA is 0.18. So this is for the second question. YA 0.18 and YB 0.82. So that is the second part of the same question. That mole fraction in vapor phase is 0.82 and 0.18. Right? Now, question number 2.6. So in question number 2.6, vapor pressure of pure benzene at certain temperature is given. Vapor pressure of pure benzene in certain temperature. So take it as P naught A. P naught A is given to us as 0.850 bar. Now a non-volatile, non-electrolyte solid. Non-volatile, non-electrolyte. That means Van Hoff factor is not required. For non-electrolytes, I is equal to 1. Okay. Now it is weighing 0.5 gram. So it is actually solute. Solute is taken as B. So solute is 0.5 gram. When added to 39.0 gram of benzene, is WA equal to 39.0 gram. And its molar mass 78 gram per mole. So vapor pressure of the solution then is P is given to us. What is P? It is 0.845 bar. So what is the molar mass of the solid substance? That we have to calculate. Molar mass of the solid substance. P naught A is given. Then actually solute is non-volatile, right? If solute is non-volatile, so vapor pressure of the solution, that is equal to, it is PA plus PB. But as solute is non-volatile, so PB equal to 0. Non-volatile means which cannot form vapors. It is non-volatile, right? So now P is equal to PA actually. That means vapor pressure of the solution is vapor pressure of benzene in the solution. When solute is added, so PA equal to 0.845. So now we apply relative lowering of vapor pressure. Formula, relative lowering of vapor pressure, because initially it has vapor pressure 0.850. When this solute is added in benzene, then its vapor pressure is reduced to 0.845 bar. So now we write according to relative lowering of vapor pressure. According to relative lowering of vapor pressure, P naught A minus PA upon P naught A is equal to XB, and that is equal to NB upon NA plus NB. But NB is very, very less as compared to Na. So solute is, see, it is 0.5 gram in 39 gram of benzene. Okay, so it is because of this Na plus Nb is almost equal to Na. So formula becomes P naught A minus Pa upon P naught A equal to Nb upon Na. Means Wb by Mb, Wa into Ma. Okay. So what we have? P naught A we have, Pa we have. Wb is 0.5 gram and Wa is 39 gram. That is given to us. See the question. 0.5 gram solute is added solid, non-volatile and non-electrolyte, weighing 0.5 gram when added to 39.0 gram of benzene. Its molar mass is also given. No need to calculate. Ma is 78 gram per mole. So everything is given to us. What is left? Mb, that we have to calculate. So P naught is 0.850 minus 0.845 divided by 0.850 equal to Wb, that is 0.5 upon 78 into Wa 39. Sorry, Mb is not given. Mb we have to calculate because mass of benzene, molar mass of benzene is given. That is solvent. Okay, so 78 to 39 into 2, it becomes 1 only. So it is 0.005 divided by 0.850 equal to 2 into 0.5, that is 1 upon Mb only, that is Mb equal to 0.850 upon 0.005, means it is 850 by 5. It is 5170. So Mb is 170 gram per mole. 170 gram per mole. 170 gram per mole. Yes, beta. Understood? Here we use relative lowering of vapor pressure. What we have used? Relative lowering of vapor pressure. Relative lowering of vapor pressure. By using this, we have calculated molar mass of the solute. So molar mass of solute equal to 170 gram per mole. Next, 2.7. 18 gram of glucose, it is dissolved in 1 kg of water in a saucepan. At what temperature will water boil? At 1.013 bar. Kb for water is given to us, that is 0.52 Kelvin kg per mole. At what temperature will water boil? At 1.013 0.013 bar. Okay, means this question is related to elevation in boiling point. So first of all, at 1.013 bar means 1 atmosphere. 1 atmosphere equal to 1.01325. So 25 is left. It is only written as 1.013 bar. Okay. So that means T naught B is given indirectly. T naught B is given indirectly because it is written as at what temperature water will boil at 1.013 bar. If glucose is not added, so we can write that boiling point of pure water that is equal to 373.15 Kelvin, right, at 1.013 bar. That is T naught B. In the question it is not given, but it is given indirectly as we have to calculate TB, that is boiling point of water in solution, or we can say we have to calculate boiling point of solution, or water when 18 gram of glucose is added in 1 kg of water at 1.013 bar. Boiling point of solution TB, and T naught B, it is boiling point of water. Normal boiling point of water is 373.15 Kelvin, and normal boiling point is at 1 atmosphere pressure. So that 1 atmosphere is given in bar. Okay, kb we have, it is 0.52 Kelvin kg per mole. Weight of solute is given 18 gram. Weight of solvent is given in kg. Okay, so you know that delta TB is equal to kbm. That means we need m. And what is m? Weight of solute, molar mass of solute. If weight of solvent is given in kg, then there is no need to multiply by 1000. WB is always in gram, molar mass in gram per mole. So we need molar mass of solute. And what is solute? Glucose, C6H12O6. 12, 6 carbon, and atomic weight of carbon is 12. 12 hydrogen, and mass of each hydrogen, molar mass of each hydrogen is 1. 6 oxygen, and molar mass of each oxygen is 16. So it comes out to be 72 plus 12 plus 96. Most of you know the molar mass of glucose is 180 gram per mole, right? Just put the values. Delta TB equal to Kb, that is 0.52. WB 18 gram. Molar mass 180 gram per mole into 1 kg. So it comes out to be, see, 18 180 10, that is 0.052. 0.052. It is Kelvin kg per mole. Okay, so it becomes 0.052 Kelvin. It is delta TB, and you know delta TB is equal to TB minus T naught B, because delta TB is elevation in boiling point. So this is the colligative property, elevation in boiling point. So it is equal to KBM, and that is 0.052. So TB is equal to T naught B plus 0.052. So TB is equal to 373.15 plus 0.052. Comes out to be 373.15 plus 0.052. That is 373.202. This is boiling point of the water, and this is the temperature at which water will boil when this 18 gram of glucose is added to 1 kg of water at 1.013 bar. Okay, 373.202 Kelvin. Next question. The boiling point of benzene is given to you. Means again T naught B. It is given to us, that is 373.23 Kelvin. Now when 1.80 gram of non-volatile solute, means WB is given, it is 1.80 gram. It was dissolved in 90 gram of benzene, means WA is also given, that is 90 gram. So boiling point is raised to 354.11 Kelvin. Means now TB is equal to 354.11 Kelvin. So what we have to calculate? Molar mass of the solute, means MB we have to calculate, and KB is given to us, that is 2.53 Kelvin kg per mole, right? So just use the relation of colligative property, that is according to elevation in boiling point. According to elevation in boiling point, delta TB is equal to KBM. M, small m, molarity is not given, so we expand it, WB by MB. WA is given in grams, so it should be multiplied by 1000. That is the formula. So delta TB, you know what is delta TB? It is TB minus T naught B into KB WB upon MB into WA into 1000. Just put the values. What is TB? It is 354.11 minus 353.23, and that is equal to Kb. Kb is 2.53. Wb 1.80 into 1000 divided by MB that you have to calculate, and WA is 90. Just now to calculate 354.11, 353.23 is subtracted from it, and it becomes 0.88. Then 2.53 into 1.80 into 1000 divided by molar mass of solute into 90. So molar mass MB is equal to 0.88 into 90 divided by 2.53, 1.80 into 1000. So now molar mass comes out to be, am I right? Oh, sorry. MB equal to 2.53 into 1.80 into 1000 divided by 0.88 into 90, right? Because just MB, we take it from denominator to the other side, and 0.88 to right side. So it becomes 2.53 into 1.80 into 1000 divided by 0.88 divided by 90. That is 57.5. 57.5 gram per mole. The answer of given question. Next question. 45 gram of ethylene glycol. You know, ethylene glycol is forming antifreeze solution. Is mixed with 600 gram of water to calculate the freezing point depression. That is, we have to calculate delta TF and TF, freezing point of the solution. See, WB is given to us, that is mass of ethylene glycol, and WA is also given, that is 600 gram. And to calculate delta TF, sorry, that is depression in freezing point, it is equal to Kf into M. See, Kf is not given, but in question it should be given. Okay, because water is there, so sometime it is not written, but it is 1.86 Kelvin kg per mole. 1.86 Kelvin kg per mole. So molality is not given, so we expand it, that is WB by MB WA into 1000. Okay, so now delta TF we have to calculate, and just put the values. Kf we have, WB we have, WA we have, but MB we don't have. So just calculate MB. We have already calculated it. 24 plus 6, 30 plus 32. That is 62 gram per mole. That is the molar mass of ethylene glycol. Just put the values. 1.86 Kelvin kg per mole into WB. What is WB? 45 gram into 1000. It is gram per kg because 1000 is written to convert gram into kg. MB 62 gram per mole into WA, that is 600 gram. Because weight of solvent is given in gram, that's why we write 1000. Okay, so just multiply 1.86 into 45 into 1000 divided by 62 divided by 600 comes out to be 2.25 Kelvin. 2.25 Kelvin. This is delta TF. This is first part. Now to calculate second part, delta TF equal to T naught F minus TF. Depression in freezing point. So TF is equal to T naught F minus delta TF. So what is freezing point of water? Obviously 0 degrees Celsius and 273.15 Kelvin. So TF is equal to 273.15 minus 2.25. So 2.25 and 273.15. It comes out to be 270.9 Kelvin. So this is the freezing point of the solution. First is depression in freezing point, and that the depression in freezing point is 2.25 Kelvin, and second part. This is freezing point of the solution. So freezing point of the solution is 270.90 Kelvin. Right? Next question. Next question is 1.00 gram of a non-electrolyte. 1.00 gram of non-electrolyte solute. So again WB equal to 1.00 gram and dissolved in 50 gram of benzene, that is 50 gram. It is lowered the freezing point of benzene by 0.40 Kelvin, that is delta TF is equal to 0.40 Kelvin. The freezing point depression constant of benzene, that is Kf for benzene, is given 5.12 Kelvin kg per mole. To find the molar mass of the solute is MB, we have to calculate. Very simple question. We have done this type of question. Just use delta TF equal to KFM. Just write, we know that. And KF is given, but molality is not given. So we expand it further. WB by MB, WA into 1000, right? Okay, so delta TF is 0.40 Kelvin. Kf is 5.12 Kelvin kg per mole. Wb 1 gram into 1000 gram per kg. Mb we have to calculate molar mass of solute, and Wa, so Wa is 50 gram. So Mb is equal to 5.12 into 1.00 into 1000 divided by 0.40 into 50 gram per mole. It is 5.12 into 1000 divided by 0.4 divided by 50. It is 256 gram per mole. So this is question number 10th. Now, yes, beta, any doubt up to this? Yes, beta? Okay. Next question. Question number 11. 200 centimeter cube of an aqueous solution of a protein. It contains 1.26 gram of the protein. Means volume of solution is given to us, and that is 200 ml. 200 centimeter cube or cubic centimeter means ml. So 200 ml of an aqueous solution of a protein contains protein 1.26 gram. So WB, because I'm taking solute as B, so WB is 1.26 gram. The osmotic pressure of such a solution at 300 Kelvin. So capital T, temperature is 300 Kelvin, and at that temperature, osmotic pressure, which is denoted by pi, equal to 2.57 into 10 raised to power minus 3 bar. Now, we have to calculate molar mass of the protein. So, here we use relation for osmotic pressure. So, we know that pi equal to CRT. Now, what is C? Concentration. But that is not given. Capital R not given. But we have to write the value of R in appropriate units. C just expanded further. It is number of moles over volume of solution in liter into RT. Volume is given in ml. Number of moles are not given. So we expand it further. WB by MB, volume in ml. So if volume is in ml, it is multiplied by 1000 into R into T. WB we have in gram. Molar mass we have to calculate. Molar mass we have to calculate. So now we need capital R. Temperature is given in Kelvin. So capital R we need in appropriate units because pressure is in bar, and volume in liter. See, volume in ml, but it is multiplied by 1000, so it becomes in liter. V upon 1000. Okay. So value of R, keep in mind, value of R is 0.0821 liter bar per Kelvin per mole. Value of R is same. It is 8.314 in joule per Kelvin per mole. But at that time, pressure should be in Pascal or kilopascal, SI units. And here, volume is in liter, pressure in bar, temperature in Kelvin. So we take this value of R, 0.0821 liter bar per Kelvin per mole. Just put the values. Pi is 2.57 into 10 raised to power minus 3 bar. Okay. Then weight 1.26 gram. Then 1000. This 1000 is 1000 ml per liter. It is written because of this. Convert ml into liter. Then capital R 0.0821 liter bar per Kelvin per mole into 300 Kelvin. The temperature is 300 Kelvin divided by MB into 450 ml. So just see, bar cancel, ml, just change the color, ml cancel, then Kelvin cancel, what is left? Okay, liter cancel, so it is gram per mole, so MB is equal to 1.26 into 1000 into 0.0821 is 821, okay, divided by 2.57 into 10 raised to power minus 3 into 450 gram per mole. So value is 1.26 into this is 1000, it is also 1000. So it becomes into 0.0821 divided by 2.57 divided by 450. So it is 89.44. I think it's somewhere we got wrong. Wait, where went wrong? Oh, 300, we have to multiply it by 300. It is left. So into 300. See, we have, oh my god, it is not, volume is not 450, it is 200. I'm sorry, volume was 200 ml. Here I got this 450. Okay, it is 200. So let me calculate again. One point 26 into 60,377 gram per mole. Just check the value. Is it correct? It should be 0. Say in liter bar per Kelvin per mole, it is 0.0821. So we have 60,377 gram per mole. 1.26 into 1000 point into 0.0821 into 300 divided by 200 divided by 2.57. Yes, it is 60,377 gram per mole. Okay, last question. Actually, 12th example we have done in our previous video. So this is the last question. 0.6 ml of acetic acid having density 1.06 gram per ml is dissolved in 1 liter of water. 0.6 ml of acetic acid. So volume of acetic acid is 0.6 ml. Density of the solution 1.06 gram per ml. So now volume and density of acetic acid is given. So from volume and density, you know, density equal to weight by volume, right? Density of acetic equal to weight of acetic acid divided by volume of the acetic acid. So weight of acetic acid in the 1 liter of water, that is equal to density of acetic acid into volume of acetic acid. So density is 1.06 gram per ml into 0.6 ml. So weight of solute in the solution is 1.06 into 0.6 means 0.636 gram. So this is weight of acetic acid. Volume of solution, because volume of water is given. Okay, so volume of water is 1 liter. And you know, density of water is 1 gram per ml. So that means it is 1 kg per liter. Okay, that means weight of solute is, the weight of solute we have calculated 0.636 gram. So weight of solvent is 1 kg. See, here weights of solute and solvent are given, but indirectly. ml of acetic acid, density of acetic acid. From here we calculate weight of acetic acid, that is mass of solute, and 1 liter of water, and density of water is 1 gram per ml. So it is solvent weight, that is 1 kg. Okay. Now depression in freezing point observed for this strength of acid was 0.0205 degrees Celsius. So depression in freezing point, delta TF, that is equal to 0.0205 degrees Celsius. So you know, depression in freezing point, it is change in temperature that is same in degrees Celsius as well as Kelvin. Okay. Now we have to calculate Van 't Hoff factor, that is I we have to calculate, and we have to calculate delta TF. Sorry, we have to calculate dissociation constant of acid, means Ka. These two values we have to calculate: Van 't Hoff factor I and dissociation constant of acid Ka. So we know that delta TF is equal to I KFM. I we have to calculate, but before that we know delta TF we have. Yes, Sanskriti, there is lot of calculation in this chapter. But if you wish to calculate exact values, use log table, because there are only 2 to 3 questions which are numerical based and which need a lot of calculation. For that you should use log table. If you wish, I will use log table in one of the question and show you how to solve by using log table without using calculator, because in CBSE calculator is not allowed. I will definitely do that. Okay, so I into KF, but molality is not given, so just expand it further. WB, MB, WA into 1000. So delta TF, that is 0.0205, 0.0205 Kelvin. I we have to calculate, and KF again it is not given, but you know KF for water is 1.86 Kelvin kg per mole. WB, what is WB? 0.636 gram. 1000 gram per kg divided by MB, that we have to, okay, MB we can calculate because it is simply acetic acid. Value we have calculated, CH3COH. For CH3COH, 24 plus 4, 28 plus 32, that is 60 gram per mole. So MB 60 gram per mole. WA, it is 1 kg. Okay, so there is no need to multiply by 1000, but as we have already multiplied, so write weight of solvent in gram. So 1000. So it is cancel. Gram, gram cancel. Here gram again cancel. Per mole cancel. Kg per kg cancel. Kelvin cancel. That means I is dimensionless. That you know all. So I is equal to 0.0205 into 60 divided by 1.86 into 0.636, right? So 0.0205 into 60 divided by 1.86 divided by 0.636, that is 1.039 or almost 1.397, 1.03976. So it is round about 1.04, 1.04 around. Value comes out to be 1.04 around. Okay, so just write it as 1.04. That is I. Now I we have. Now to calculate Ka, dissociation constant of acid, Ka, that is equal to C alpha square over 1 minus. Thank you, Sanskriti. C alpha square over 1 minus alpha. So, oh, here we need C. And you know, we did one mistake that when these values we have taken, so if we calculate this separately, then our calculation become somewhat simple. So M is WB by MB WA into 1000. So what is WB? 0.636 into 1000 divided by MB, that is 60, and oh again 1 kg, matlab 1000 cancel, because 1000 is written only when weight is in gram. As weight is in kg, so there is no need to write. So we have to write WA in gram. Okay. So molality comes out to be 0.636 divided by 60, means 0.0106. This is molality in mole per kg. Alpha we have, that is 1.04. Alpha is 1.04. So just put the values. So Ka equal to 0.0106 into 1.04 whole square divided by 1 minus 1.10. Sorry, somewhere we went wrong. Oh, I, we have calculated I, not alpha, sorry. So first we have to calculate alpha, that is, say, acetic acid in water. So Van't Hoff factor, it is 1.04. So from here we have to calculate degree of dissociation. Okay. So degree of dissociation for dissociation of acid alpha, that is degree of dissociation. Oh, sorry. Degree of dissociation. So this degree of dissociation equal to I minus 1 divided by n minus 1. So what is n here? Actually acetic acid, when it dissociate in water, it form acetate ion and hydronium ion. That means n for this is 2. N is how many ions it will give, how many particles it will give on dissociation. N is 2. So from here alpha is equal to I minus 1 upon n minus 1. That is alpha is equal to 0.04. So value of alpha is, see, 1.04 minus 1. So 0.04 divided by 2 minus 1. So 1. So alpha is 0.04. Now K is C alpha square over 1 minus alpha. C we have calculated, that is 0.0106 into 0.04 whole square divided by 1 minus 0.04. So Ka equal to 1.06 into 10 raised by minus 2, 4 into 10 raised by minus 2 whole square divided by 0.96, 1 minus 1 minus 0.04. So it is 1.06 into 10 raised per minus 2 into 4 4 is 16 into 10 raised per minus 4 divided by 0.96. So it is 16.96 17.6 17.67 into 10 raised per minus 6 is 1.767 into 10 raised per minus 5. Okay. See, so alpha we have calculated, it is 1.04 and Ka is equal to 1.6767 or 1.77 into 10 raised per minus 5. So that's it. So these are all questions, examples means of solution chapter. Any doubt? Okay, then you can leave the class now. So I again request all of you to share my channel with your friends. It is your duty to make my channel to grow. See, in this platform on YouTube Live, I will complete the CBSE board exam questions, NCRT concept, NCRT exercise, NCRT in text question, NCRT example in my own way, and after that I will complete NEET previous year questions chapter wise, JEE previous year questions chapter wise, and then full length papers of CBSE board exam, NEET exam, JEE exam, and this is all free of cost. So do support my channel, share with your friends. My only concern is that I should reach the masses, and it becomes a trend to have free education, to save hard earned money of your parents, so that you will not spend your father or mother's hard earned money in this coaching mafias. My only concern is that, because your parents are earning by doing something, either by a job or a business, and this is all hard earned money. Not They are not looting the public. Okay, so don't spend it, or don't means waste it. If you get it, quality education free of cost, so why not to take it and uh, grab this opportunity? Ask your friends to join. I will definitely help you to crack any exam. I was in Akash Institute for 5 years, and then I was in uh, schools, various schools, BPS, ODA, KVs, and now I am working as an assistant professor. But my concern is only that I love 11th, 12th, teach 11th, 12th. So I'm working on it to support my channel and share with your friends, so that all will subscribe and my community will grow. That is only is I said a Guru Dakshina to me. Thank you all.